A happy morning to another person here. Today we discuss about what are the fundamental concepts in computer networks. Okay, myself, Dr. C. Anand, Associate Professor in Computer Science and Engineering, KSR College of Engineering, Tiruchengur, Namakkal districts in Tamil Nadu. Okay, today we discuss about what do you mean by data communications, then networks. Okay, first of all, first, what is data communications? The term telecommunication means communication at a distance. Okay, communication at a distance. The word data refers to a information. Okay. It is an information presented in whatever form is agreed upon by the parties creating and using the data. Okay. Finally, data communications are the exchange of data between two devices, either via some form of transmission medium such as a wire, cable or wireless. Okay. Finally, data communications are the exchange of data between two devices. In, it is used in either wired medium or wireless medium. Okay. What are some characteristics of the data communications? First one is a delivery. It's a correct destination, whether it is reached data in correct destination. Then accuracy of data, that is called as an accuracy. Timeliness, that is a real-time transmission. Jitter, that is an uneven delay between the due to some traffic. Okay. These are the fundamental characters of the data communication. First one is the delivery, accuracy, timeliness, then jitter. Next. Here we discuss about what are the components of data communications. Message, sender, receiver, medium, protocols. There are 5 components in the data communications. First one is the data communications. First one is a message. Message. The message is the informations to be communicated. Okay, information nothing but data. Data in terms of either text message, numbers, pictures, audio, and video. It can be any format. That is a data to be communicated. That is called as a message. Next, sender. Who are all the sender that can send the message, data message? That is, the sender is the device that sends the data message. It can be a computer, workstation, telephone handset, video camera, and so on. Next, receiver. The receiver is the device that receives the message. It can be a computer, workstation, telephone handset, television, and so on. Next, fourth component is the transmission medium, either wireless medium or wired medium. Okay, the transmission medium is the physical path by which a message travels from sender to receiver. Some examples of transmission media such as twisted pair cable, coaxial cable, fiber optic cable, and radio waves. Next one is a protocol. It is a the exchange of data between two devices. Okay, it is a set of rules that govern the data communications. Okay, it represents an agreement between the two communicating devices. Without protocol, the devices may be communicated but not communicating. That is, just a person speaking French cannot be understood by a person who speaks only Japanese. Here, therefore, protocol is a set of rules that govern data communications. Okay, these are the 5 components. First one is a message, sender, receiver, transmission medium, and protocol. Next, data representation. All of you already told that data representation either is a text message, either numbers, images, audio, and video. Okay. Next, how do you flow the data between the source and destinations? First one is a data flow. Here 3 types of data flow. First one is a simplex methodology, half duplex methodology, then full duplex methodology. In diagram shows that first one is a A diagram shows that is a simplex methodology. That is a unidirectional data. Okay. Second one is a half duplex. That is direction of data at time 1 interval, then direction data at time 2 interval. That is example for walkie-talkie. Third one is a full duplex methodology. Okay, communication between the two devices at all the time. Here, okay, first a simplex mode. The communication is a unidirectional, as on a one-way street. That is, only one of the two devices on a link can transmit. The other can only receive. Diagram shows that either server sends a data to the monitor. Therefore, only one of the two devices on a link can transmit. The other can only receive. Here, some examples of this simplex methodologies, keyboards and traditional monitors are the examples of simplex devices. Next, half duplex. Okay, in half duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. Here, examples of half duplex methodologies, walkie-talkies and citizens band radios are both half duplex system. Next one is a full duplex methodology. Both stations can transmit and receive simultaneously. In figure shows that okay, both two devices can communicate simultaneously. One example of full duplex communication is the telephone network. All of you know telephone network. When two people are communicating by a telephone line, both can talk and listen at the same time. Therefore, the full duplex mode is used when communication in both direction is required all the time. These are the data flow methodologies. One is the simplex, half duplex, then full duplex methodologies. Next, what in by network? Okay. How to communicate the devices? That is how to connect the devices. Okay, a network is a set of devices, that is nodes connected by communication link. Therefore, a network is a set of devices, that is nodes connected by communication links. A node can be a computer, printer, or any other device capable of sending and or receiving data generated by other nodes on the network. That is called as a network. Therefore, finally, a node can be a computer, printer, or any other device capable of sending or and or receiving data generated by other nodes on the network. Okay, what are the types of connections? How to connect the nodes? Here, there are two types of connections available. One is a point-to-point connections, other one is a multi-point connections. First diagram shows that here both workstations, only two types of workstation is available. There is a dedicated link is provided between two devices. Okay, the diagram shows that a dedicated link between in the two devices, that is called as a point-to-point link. A link that provide either wired medium or wireless medium. Second diagram shows that there is a wireless medium. They are via satellite networks or internet service provider. Okay. Second one is a multi-point. That is more than two specific devices share a single link. Yeah, more than two specific devices share a sync link, that is called as a multi-point or multi-drop. There are two types of one. One is a point-to-point, and then is a multi-point connections between the two devices. Next, how to connect the nodes? That is a physical structure of the devices. That is called as a physical topology. Yeah, here different types of topologies available. First one is a mesh topology, star topology, first topology, ring topology, then finally tree topology. Okay, first mesh topology. Here, 5 nodes are connected, fully connected. Therefore, each device has a dedicated point-to-point link to every other devices. Each device has a dedicated point-to-point link to every other devices. That is a dedicated link here. Dedicated link carries traffic only between two devices it connects. A fully connected mesh network has n physical channels to a link n devices. Yeah. Therefore, a fully connected mesh network has n into n minus 1 by 2 physical channels to link n devices. Every device on the network must have n minus 1 input or output ports. That is called as an IO ports. Therefore, is a dedicated link. That is, it carries traffic only between two devices it connects. Next, what are the advantages means? Less traffic. There is a dedicated between the two devices. Therefore, less traffic. It's a strong connection. Security is also provided. Easy to maintain. Is there any problem occur? Easy to recovery. Then therefore easy to maintain is also easy. Next, disorder is a need more resources. Then that is called as an resource in terms of cables and ports. Need more resources and expensive. Okay, that is a fully connected mesh network means has n into n minus 1 physical channels need. Therefore, it's a more number of cables are need and more number of input ports are need. Therefore, it's a highly expensive. It's a star topology. Here, each device has dedicated point-to-point link, only a central control, usually called a hub. Here, diagram shows a central is that is called as a hub. Through hub, devices can be connected. No direct traffic and link between the devices. Okay, what are the advantages? Means it's a less expensive, easy to install and reconfigure, then robustness. Okay, this is less expensive, easy to install and reconfigure, robustness. What is this disadvantage? That is a single point of failure. That is, if hub fails, the entire connection is fails. This is a main drawback in this star topology is hub. That is a single point of failure. Next is a bus topology. There is a single link and share entire devices. That is called as a multi-point or multi-drop topology. It is also known as a multi-point or multi-drop topology. All devices are linked through a backbone cable. This is a only one cable and share the all the systems. Okay, here drop line and tab is connection is also there. Nodes are connected to the bus cable by drop lines and tabs. Okay, by drop line means a connection running between the device and the main cable. That is called as a drop line. The diagram shows that here drop line a connection between the devices and the main cable. Tab nothing but a connector that either splices into the main cable and punches the sheathing of cable to create a contact with the metallic core. That is used for the tab. The main advantage is nothing but is the easy of installation. Yeah, next one is the disadvantage is it is a difficult reconnection and fault isolations. There is a broken or fault of the bus cable stops all transfers. Suppose bus cable main drops means that is bus cable either failure or broken means the entire connection is stops. Okay, this is the first topology connections. Next, ring topology. It is a formation of ring. Each device is dedicated point-to-point connection only with two devices on either side of it. Here, a signal is passed along in the ring direction from device to device until it reaches its destination. Each device in the ring incorporates a repeater. What are the advantages? It is a relatively easy to install and reconfigure. Then also fault isolation is a simplified solutions. This one is a unidirectional traffic. This is a main. This is a unidirectional. Only device is nearby station. Then next nearby stations. Also data is transmitted. Okay. That is called as a unidirectional traffic. Okay. Here, repeater is used for the reproduce the signals. That is called as a repeater. Next, tree topology. That is called as an. It is the tree topologies integrate multiple topologies together. Okay. Tree topology integrates multiple star topologies together onto a bus. A central bus is available in this diagram shows that it is a integrate multiple star topologies together onto a bus topologies. It is called as a tree topology. What are the advantages means point to point wiring for individual segments supported by special several hardware and software vendors is also there. What are disadvantages? Overall length of each segment is limited by the type of cabling used. If the backbone link breaks, the entire segment goes down. More difficult to reconfigure with and wire than other topologies. This is a complication process. Therefore, that is a, if the backbone line, that is a main bus cable breaks, the entire segments goes down. More difficult to configure and wire than other topologies. This is a integrate multiple topologies, very complicated. Next, this is a hybrid topology. It is a combination of a star topology with three bus networks. Okay, this is here topology. Yellow color is the hub topology. That is a hub is a central hub. That is a star configuration. Here connected with the three bus networks. This is a hybrid topology. Next, next one is what are the categories of networks? That is a local area network, wireless area network, metropolitan area network, wide area networks. Okay, local area network is a connection between the buildings. That is called as a local area networks. Is a next one is a metropolitan area network. Is connected between the metropolitan areas. Next, wide area is all over the world. Next, what do you mean by protocols? Already told that protocol is a set of rules that govern the data communications. It is a synonymous with rule. Standards are agreed upon the rules. This nothing but protocol is a synonymous with rule. Standards are agreed upon rules. In general, protocols is combination of syntax, semantics, and timing. Syntax is a format of the data. Semantics meaning of each section. Timing when data should be sent and how fast. Yeah, protocol is a combination of syntax, semantics, meaning that is a format of the data, meaning of the each section, then when data should be sent and how fast. Standards. These are based on the five fact by law. Yeah, it is based on the standards. Okay, that is called as an de facto, de jure. That is a de facto simplify fact, de jure nothing but a by law. Okay, was some of the standard organizations. That is a ISO International Standard Organization, ITUTT International Telecommunication Union Telecommunication Standards, then ANS American National Standard Institute, then IEEE, then EIA. These are the standards for the protocols. Next, addressings. In each network, some levels of addresses. There is a 4 levels of address are used in the internet, employing the TCP/IP protocols. There is a physical addressing, logical addressing, port addressing, and specific addressing. That is a physical addressing. Yeah, this is a physical address mainly based on the 48-bit address written in a 12 hexadecimal digits. Every byte to hexadecimal is separated by colon. Here 07 colon 01. Okay, 07 terms of that is a 2 hexadecimal digits. Okay, therefore total 48 bit, that is a 6 bytes. This physical address are imprinted on the NIC, that is a network interface card. Okay, most local area networks, that is Ethernet, use a 48-bit, that is 6-byte physical address written in a 12 hexadecimal digits. Physical address, known as also known as the MAC address. It is the address of a node as defined by its LAN or WAN. It is included in the frame used by the data link layer. The physical address of in the datagram may change from hop to hop. Okay, it is a change from hop to hop. It can be physical address will be a change. Next is logical address. It is a universal communication that are independent of physical networks. The IP addresses are necessary for universal communication that are independent of physical network. No two host address on the internet can have the same IP address. Okay, IP address in the internet are 32-bit addresses that uniquely define a host. The physical address will change from hop to hop, but the logical address usually remain the same. Next one is a port address. It is a 16-bit address represented by one decimal numbers ranging from 0 to 65,535 to choose a process among multiple processes on the destination host. Yeah, destination port number is needed for every data delivery. Source port number is needed for receiving a reply as soon as acknowledgement. In a TCP/IP, 16-bit port addresses represented as one single number, that is a 753. The physical addresses change from hop to hop, but the logical address and port address are usually remain the same. But the logical and port address does not change, but the physical addresses changes from hop to hop only will be changed. Specific next one is a specific, that is a domain address. Email address, that is a user at ksu at edu.sa, that is a universal resource locator. The domain systems translates human friendly computer host names URL into IP addresses. Yeah, that is for example www.exam.com is translated to 208.77.188.166. Okay, these are the specific address for the networks. Okay, that's all about this session this time. Here, thank you, one and all person here. Thank you very much. Thank you.